Welcome back to Maths with Mrs. J. This is going to be our final video in our brief expansion series. I wanted to talk about some special cases here. Now, the good news is that even if you don't recognise these as special cases, if you do have a perfect square, so something squared, something plus something squared, or something minus something squared, you could, if the worst comes to the worst, just write out that bracket twice and use your FOIL. For example, say you had to do x plus 3 all squared and you couldn't remember your rule. You could do x plus 3 times x plus 3 and then do your FOIL, right? It is far better, however, to remember your rules. So let's go through these rules. Okay, I'm just going to use our area example for the a plus b squared. So if we have a plus b times a plus b, that's a big square, isn't it? So that's your a plus b squared. That can be divided into, well, this is a square, this is a square, this is a rectangle, and this is another rectangle. Let's see what they are. Well, this is a by a, so that's a squared. This is a by b, so ab. This is b by a, which is ba, which is really the same as ab, isn't it? Doesn't matter with multiplication which order you do it in. And this little square here is b squared. So when you do that expansion, you get your a squared, you get your b squared, and you get 2 ab's. A lot of people, for some reason, seem to think that that a plus b all squared, they seem to want to just put a squared plus b squared and they forget their middle term. Please don't be one of those people, all right? Be really, really careful with that. Now, the difference with a minus b squared is just that this sign here is minus. This one's still a plus because negative b times negative b is still positive b squared. So bear that in mind. Then our other one, which we could also work out by just expansion, is our difference of 2 squares. Now, if you were to do your FOIL with that, you'd get a squared minus ab plus ba minus b squared. Your middle term will actually go. Now, this is actually a super cool and super useful thing to remember. We actually use this notion in a lot of topics. We use it in surds so that we can deliberately multiply by a version of 1 that will rationalise a denominator. We use it in complex numbers so that we can do our divisions. We use this quite a lot when we're factorising, so we're going back from this stage to this stage. So it really is a very, very useful and powerful tool that you can have in your toolkit, so do pay attention to that one. Let's go through these examples. Let's try and do it without having to do the FOIL, all right? I want you to try and get used to using the pattern. So the pattern says that we're going to have first thing squared, so a squared, plus 2 times a times b plus b squared, okay? First thing squared plus 2 times first thing times second thing plus second thing squared. Now, this is going to end up with x squared plus 2x plus 1. You could get there by doing x plus 1, but it's way better if you can recognise the pattern. All right, using our pattern here, first thing squared plus 2 times our first thing times our second thing plus our second thing squared. So we get x squared plus 8x plus 16. This one's going to be the same sort of thing, but we're going to have a minus. So we're going to get a squared minus 2 times a times 3, which is 6a, plus our 3 squared, which is 9. If you need to put in an interim step, put in an interim step. But if you can do it without, then that's great. Okay, let's see if we can manage this one without the interim step. First thing squared, 2y all squared is 4y squared, minus 2 times that, which is 4y, times 5, which is 20y, plus our 5 squared, which is 25. As I said, if you need an interim step, do your interim step. Okay, what have we got here? We've got 2 brackets with the same 2 terms in both, and one bracket has a plus and one bracket has a minus. We should recognise that this is just going to be first thing squared minus second thing squared. Our middle term's going to drop out. If you were to do your FOIL, you would get x squared minus 2x plus 2x minus 4, and the minus 2x and plus 2x would cancel each other out. It doesn't matter with your difference of 2 squares whether you have your minus bracket first or your plus bracket first. Remember, multiplication is commutative. The order doesn't matter. As long as one bracket is a plus and one is a minus, then you can use that rule. As, of course, the terms have to be the same. All right, what's this going to be? Well, it's going to be 4x all squared minus 1 squared. What's 4x all squared? It's 16x squared. And 1 squared is, of course, 1. Again, we've got the same pattern happening. We've got our a plus b, our a minus b. What are we going to get? We're going to get y squared minus, what's 2x all squared? It's 4x squared. Okay, again, we've got the same pattern. We've got something minus something, something plus something, and these things are the same and these things are the same. So we're going to get, in this case, what's x squared squared? It's x to the 4th, isn't it? 7 squared is 49. Now this one here, I want us to take a bit of notice of. First thing is that normally with this, you would actually use the factorisation element of difference of 2 squares to put this into 2 brackets and go from there. However, our instruction here was to expand and simplify. So we're going to expand this first one to give us x squared minus 2 times x times 2, so minus 4x plus 4. Then we're going to take away, and I'm going to put brackets around this to make sure we take away the whole lot. 3x all squared is 9x squared. Plus 2 times 3x is 6x times 1 is still your 6x plus your 1. So tidying this up, we're taking away 9x squared, we're taking away 6x, and we're taking away 1. So tidying up again, x squared minus 9x squared is minus 8x squared, minus 4x minus 6x is minus 10x, plus 4 minus 1 is plus 3, and there you have it.